What is WebAssembly or WASM? Imagine a world where you can leverage Rust, C, C++, C Sharp, Go, and for our DoD team, even COBOL, with native performance and run those in a web browser without requiring any custom software installation or silly plugin. Well, welcome to the wonders of WebAssembly. That was made possible when WebAssembly officially became a new web language approved by the World Wide Web Consortium W3C. Unlike languages like JavaScript, which uses the concept of just-in-time compiler, WebAssembly is compiled before execution and brings tremendous performance increase. First, let's take a look at how this works. You see those .wat file or WebAssembly text files, and they allow the text representation of WebAssembly. .wasm files, WASM, are compiled WebAssembly files. They are binary files that will run on all modern browsers. So effectively, you can take your native code, compile it using WebAssembly as a target, and run those in your browsers. To be clear, WebAssembly is not a programming language, it is a compilation target which can be deployed on the web for client and server applications. There are now dozens of languages supported by WebAssembly. Some will run in the browser, some in CLI, and some in what we call WASI, other one known as the WebAssembly System Interface. But for all of you yelling, but what about JavaScript? Is JavaScript dead? To be clear, WebAssembly is not meant to replace JavaScript. Most teams will continue to use JavaScript frameworks for UI and more, but if you're really interested in native performance, you can easily embed WASM into your page to get performances that you would never be able to achieve in JavaScript. You could, for example, have a Unity project in C# and build it into WASM while the rest of the page is still using the React framework, for example. Or if you take a look at some companies leveraging performance-intensive design capabilities like Adobe or Figma, for example, Figma uses React for the UI, but the actual design engine is in C++ using WASM. One of the most popular WebAssembly tools is without a doubt Emscripten, which will convert from native language to WASM. So let's take a look at a simple Hello World example. Check out James Mackenzie's blog in the video description below to find more. Step 1, we'll take a very basic Hello World example in C. Here it is. Step 2, build your C code using the Emscripten build command. Step 3, check the results of your build. You should now have your C file compiled in WASM and a JavaScript and HTML file. The JavaScript is used to load the WASM into the HTML browser. Step 4, run the HTML and voila, you're running C code in your browser. How cool is that? So when do you really need this? Well, anytime you need very high performances, whether it's 3D graphics, complex visuals, complex compute-intensive algorithm, complex image manipulations or object detection, and more. That being said, there are some limitations: no multi-threaded support and no garbage collection. There you have it. Use WebAssembly for performance-intensive operations and continue to stick to JavaScript for all traditional UI and UX front-end experiences. WebAssembly is booming and its future is bright. We're just getting started, and it seems its future will get beyond the browser as many cloud service providers are running WASM in containers as well. Companies like Fermyon are bringing streamlined developer experience and production WASM capabilities to life to streamline WASM adoption. WebAssembly can also be leveraged to bring legacy applications into the browser, but let's be careful there, as this can be a terrible user experience. So if you too are excited to run your legacy Doom 3 game in your browser, try out in the links in the description below.